My name is Oksana Dabro. I'm an innovation project manager and technical textile area at textiles.cat. We are rebranding now. This is a cluster for advanced textile materials in Catalonia. Today, this webinar will be held by myself and also by Pepe Costa, a CEO of Recycle. He is expert in sustained traceability and ethical sourcing across the textile industry value chain, which will be the second part of this webinar. This is the agenda for today. I will make a short introduction in the xBUILD-EU project. As well, we will go through the green technologies in textile and their importance in addressing environmental challenges. Also a short dive into the key regulation and standards for the green technologies in textiles. And as well, from my side will be some innovative products as a conclusion and also application of green technologies in textiles with some examples. And the last point before the question and answer session will be the part which will be presented by Pepe about supply chain traceability platform from raw material to the final garment. Now a bit about the xBUILD-EU project, which is a cross-fertilization of industrial ecosystem in textile manufacturing, construction, and also advanced manufacturing. It's advanced technology to build up green and digital resilience in Europe. For this project, we have 5 participants from different countries in Europe. And the objective of this project is to build a new strategic partnership focused on cross-sectorial collaboration and cross-fertilization across textile construction and advanced technology, and working as a catalyst to deploy green solution and more digital Europe that enables smart living. So these are the objectives, and this objective will be executed via different cross-sectorial collaboration between the cluster, via network training, via vouchers, grants, as well via webinars as today, which will be a series of 5 webinars. As well, in this objective is coming also training cluster staff to implement co-creation activities with their members and to define the future strategies. Today we will have also later on after this webinar also a second call info day about the voucher schemes and the second call. This is the information about the second call. You still in time to register. It's at 12 o'clock. It's about launching the second call for proposal with a total budget of 540,000 euros. And these grants and vouchers are about the Innovate, Green and Digital and Global vouchers for the SMEs. And now we are at the second webinar. This 5 series of the webinar and the workshop are already started. First webinar in construction we did have on 3rd of July by CCS from Slovenia. You have it already available on YouTube on the xBUILD-EU channel. And today we will have the textile, exploring the green technology in textiles. The next webinar will be held in September digital, and as well the workshop. And now I would like to go straight away for the green technologies in textile and explore a bit about the innovation application, and also Pepe will tell about traceability. The green technologies in textile is about innovation and practices that aim to reduce the environmental impact of textile production and consumption, and as well is designed to improve sustainability through the life cycle of textile product, from raw material sourcing and manufacturing to usage and disposal. We was seeing a lot of challenges for the textile value chain. Many challenges that needed, of course, some solution, like high cost of the raw material, high cost for the resources, energy or water, disruption in the textile value chain, missing the turn on circular economy and green and less consuming processes. A lack of skilled personnel and aging workforce is a huge challenge in textile. Lack of performance, automatization, traceability, optimization, and monitoring. And as well, two more challenges are the poor planning, considering the fast shifting of the market, and poor estimation of the short-term and long-term risk assessment for the whole textile value chain, which must be mitigated. The key aspect of the green technologies in textile, I would mention 5 as a key aspect: about sustainable materials, eco-friendly dyeing and finishing, energy efficiency, waste management and recycling, and water conservation. If we are talking about the key aspect of green technology in textiles, sustainable materials, we would refer to organic fibers, which are cotton, hemp, bamboo, which require fewer chemicals and water. And the recycled fibers, which are incorporating post-consumer and post-industrial waste into new textile products, such as recycled polyester from PET or PET bottles. These are the sustainable organic fibers, like organic cotton, also cotton, recycled cotton, kapok, which needs not so much use of water. And some of them also don't use pesticides, so it's important to look forward in the future for such sustainable fibers. Kapok is also a great fiber, but of course there are plus and advantages and disadvantages. In this case, it's a great fiber, don't need at all water, pesticide, and so on. It's growing up, but it's short, so need to be mixed with other fibers. More organic fibers like hemp, flax, abaca, and coir. Flax, I see it a lot, and later we will see some examples. More organic fibers, jute, rami, bamboo, corn. Some have advantages, some are very expensive. Some uses chemicals as well in order to be more soft or more drapable. For also this range of this organic fibers, it's very interesting for the technical textile right now, for automotive, for composite, and so on. And additional, we have organic artificial fibers, which also are very interesting to look for sustainability as well, as chitosan, polylactic acid fibers, aliglad, viscose rayon tencel, very famous for the clothes, mint plant fiber, milk fiber, coffee fiber, orange fiber, tea fiber, and soya, and many more. So there are a lot of fibers actually. There are many pros and cons for this organic fibers. Mostly need a mechanical process, This is and also they are byproducts in some cases. As shown before, it has a wide variety of fibers, and also by mixing or blending these fibers, it's allowed to improve properties. As well as possible to recycle this fiber mechanically or chemically. The contrast will be that these fibers are very fragile and rigid. So you need chemical treatments, for example, for the wool, and a lot of water, energy, waste, and so on. So need also extra chemical agent to gain durability, and some are patented or trademarked. This gives some limitation in producing such fibers. That's why I was mentioning also this sustainable organic fibers, as we found it as well on the exhibition of textile in Frankfurt, that most of the companies are looking forward for the sustainable. In this case, we see linen and hemp, which has a lot of success at the moment. Due to properties and as well of the wide range of possibilities of applications. And now the second part of this key aspect is recycled fibers, which also are normally from PET. Everybody knows it's from PET plastic, but as well, I would like to mention here that it's possible also to recycle, also performing yarns or textile. In this case, we see some pararamid fibers. These are rest from sleeves that are sorted out, are forming the web by carding, afterwards spinning and getting the yarn again. And it's a great possibility to have new product. The second key aspect, as I mentioned, of the green technology in textile is the eco-friendly dyeing and finishing. In this case, we have different or several kind of waterless dyeing techniques, like the supercritical carbon dioxide done by Dyco, which is waterless, which means use no water and practically no chemicals. So there are many advantages of this dyeing, and the most important is, of course, that they have no water consumption. Other eco-friendly dyeing and in finishing are the natural dyes, which are derived from plants, insects, and minerals, which are biodegradable and non-toxic. In this case, was a project that was using 30% less water and less energy, but getting a really intense color, which is every time an issue, and keeping the quality of the fibers for natural fibers like linen and cotton. Another, shortly, only some examples is the foam dyeing and airflow dyeing, which also are green dyeing technologies, which don't use water. So there are some challenges, of course, of this dyeing. If you have this natural fiber, which we was seeing at the beginning, it's of course difficult to get intense color out of this bast or cellulose fibers, and need extra chemicals, swelling agent to absorb the colors, and other chemical modification of the natural fiber to achieve the desired result of the color intensivity. But there are many advantages. So there is no need for wastewater treatment and no water pollution. Also, any location is possible for this installation or this dyeing capacity manufacturing, since no water is required. As well, no auxiliary chemical needed. so mostly for polyester. No substrate drying process is needed, as this dyeing is at the end finishing with the drying the fabric. So at the end of the cycle, you have a drying fabric textile. We are moving to the next key aspect of the green technology in textile, which is energy efficiency. Of course, here we would mention the utilizing solar and wind and other renewable energy sources in textile manufacturing processes. As well, would mention the advanced technology that consume less energy and reduce waste during production. In this case, efficient machinery, these are the new machines, and they are, of course, need some investments. In the case, there are still some manufacturers have older machines, so there could be the manufacturing process efficiency by process planning and digital transition. The next key aspect of the green technology in textiles, the waste management and recycling. So here I would mention the zero waste design, designing patterns that minimize fabric waste, and textile recycling, which is very important because it's reducing the landfill waste, and as well we are getting from the old textile new yarn, new spinned yarn, new fabrics. We are able to weave new textiles. Some examples of the zero waste design, for example, in fashion, we would have the clothing patterns which are created to use every inch of the fabric, leaving no scraps behind. So there are special techniques and also a lot of softwares like 3D body scanning, and Lectra has some softwares. And yeah, the zero waste packaging aims to eliminate single use of plastic and non-recyclable material in product packaging. So, for example, biodegradable materials, reusable containers, etc., or plants, leaves. Zero waste architecture involves designing, building, and structure with materials that can be fully recycled or reused at the end of their life cycle. And the last example will be the manufacturing weaving process, for example, by utilizing softwares to create weaving patterns that maximize the use of entire fabric roll. As well, it's important maybe to implement on-demand manufacturing process, so only by order. And not less important will be to establish a closed loop system where any fabric scraps or cuts generated during the weaving process are collected and recycled back into the production cycle. Next key aspect of the green technology will be the water conservation, which is important here to mention that there are closed loop systems for recycling water within the production process to minimize freshwater use. This is happening by capturing and treating wastewater from dyeing and finishing process. Manufacturers can use it multiple times and significantly reducing the need of fresh water. As well, efficient water usage. There are special technologies that reduce water consumption in dyeing and finishing process, as we were seeing some examples before. The waterless dyeing, as well rainwater harvesting, which is installing some systems to collect and store rainwater for use in various stages of textile production. Like, for example, washing, dyeing, cooling, decreasing the this is decreasing the reliance on municipal water supplies. These are some examples of water conservation. Here we have, for example, they use more systems, but some like closed loop system from Lansing Group is using this for the production of the well-known or the tencel and lyocell fibers. The efficient water usage is the DyeStar. This is a dyeing company, and they are the The process is a continuous dyeing process for cotton and cotton blends that reduce water usage by using minimal water and energy. So this is happening by controlled steam and air, and is significantly lowering the amount of water required comparing to traditional dyeing methods. And the last one, rainwater harvesting, a company from India, Arvind Limited, and they has implemented this rainwater harvesting systems at its manufacturing plants. And here I would like to conclude this point with why it's important to address environmental challenges. For reducing pollution, green technology are helping minimize chemical pollutants released into the environment during textile production. Very important, conserving resources. Sustainable practices reduce the consumption of water and energy, vital resources that are often depleted in traditional textile manufacturing. Mitigating climate change by reducing greenhouse gas emission and energy usage, green textile technology contribute to fight against climate change. Promoting circular economy, emphasizing recycling and waste reduction, support a circular economy where materials are reused and recycling, decreasing the reliance on virgin resources. And the last one is enhancing human health, reducing the use of toxic chemicals in textile production, protects workers and consumers from harmful substances. So overall, the green technology in textiles play a crucial role in addressing environmental challenges and promoting sustainable practices in textile industry. Now we would go for the next point of our agenda, the key regulation and standards for the green technology in textile, exploring the essential regulation and standards governing green technologies in textile production. This ensures the adoption of eco-friendly practices to reduce environmental impact on textile manufacturing, and the importance of compliance, adherence to regulations promote sustainable textile production, enhancing environmental prevention and social responsibility, a global standard impact, drive to innovation and competitiveness in the textile industry. And compliance challenges, navigating complex regulation can be challenging for textile manufacturers, requiring strategic adoption and investment in sustainable practices. Innovation drivers, regulations serve as a catalyst for innovation, fostering the development of cutting-edge green technologies in the textile sector. And the future sustainability trends, anticipated advancement in regulation are expected to shape the future of sustainable textile production and driving industry-wide transformation. Also, there are some collaborative initiatives. It's very important that it has a crucial partnership between regulators, industry stakeholders, and fostering compliance and sustainability in the textile sector. Consumer awareness impact is increasing awareness among consumers about eco-friendly certification, influence market demand, driving the adoption of sustainable textile products. There are also some benefits of regulatory compliance include enhanced brand reputation, risk mitigation, and positive environmental impacts, creating competitive edge in the market. And also we can follow the innovative case study by exploring the studies of successful innovation. Will showcase the potential for sustainable growth and market leadership in the textile industry. So there are some key regulations like the European Green Deal. I would not deep dive in this, but it's just to mention, and as well EU waste policy. They have also you can find specific policies for example for different product. Also there are some the Waste Framework Directive also, that it's coming from 2020 next year. That the EU member states must establish separate collection system for used textile. But I would like to now to come to more specific standards. The family of ISO 14000, which covers all the aspects which are important in textile, maybe for different departments, which are including the operation, water management, energy management, waste management, and air quality management as well. There are some, what we mentioned previously about the zero waste. I found this useful, this DIN spec 91436, which is referring to a model for operational waste and recyclable management oriented toward a vision zero waste. Also, a general textile, it's also a series or a family of standards, which is ISO TC38, which is also of a standardization for several kinds of tests, which is important also in this case for the green technology in textile biodegradability tests, environmental aspects, traceability, ethical and environmental issues in the textile supply chain, microplastic, etc. As well, if it's interesting for the SMEs to search the EU GPP criteria for textile product and service, which I found interesting. And for this point, we would have also the certification, which of course, depending on product, which has the manufacturer, if it's a wool or cotton or different, they are also available on the market with this licenses you can buy it. Of course, there are advantages and disadvantages, but mostly it's a way to show that the textiles are certified and licensed as a green technology. And now I would go shortly only for innovative products. Only some examples. We are speaking in this case about the biodegradable fabrics, recycled materials, and plant-based dyes, as we were seeing before. Also, which is important here, it's reducing the environmental impact and promoting the sustainability in the textile industry. So also the waterless dyeing, what we was talking previously, energy efficient manufacturing, digital fabrication techniques, and so on. Some examples: the Boltritz Milo is a later alternative made from mycelium, the root of structure of mushrooms. It is biodegradable and provides sustainable option for fashion and accessories. Milk is made out, is also biodegradable fabric made from casein, a protein found in milk. Econil regenerates nylon waste from landfills and oceans into new high-quality nylon. Now we would refer to the plant-based dyes. Stony Creek colors, well known for the denim, plant-based indigo dyes. Colorfix use engineering microorganisms to produce and fix dyes directly onto textile as a water efficient and environmentally friendly manner. For recycled materials, an example is Patagonia's recycled polyester garments from PET and bottles, reducing waste and promoting a circular economy. Some cutting-edge application of green technology: the waterless dyeing, I mentioned previously, the DYCO technology. As well, we have the Tesian's EcoCircle, which is energy efficient manufacturing. H&M with the conscious collection, and as well for digital fabrication techniques, Unmade offers on-demand digital knitting technology that reduces as well waste and producing only on order. These are some if we are talking about the EU directives and that most of the clothes must be repaired, maybe I found it interesting, some examples. They are already on the market, for example, like the self-healing fabric. There are some trials or some researches in the Penn University, or I found it interesting about the self-healing textiles. Maybe it's a solution in the future. It's a question. Also, I found it relevant if it's everything self-cleaning, lotus effect, which is also already used in trains, for example, or planes. And as well has a lot of property. And of course, this would be an approach for saving energy or cleaning or use of water and so on. And last but not least, I would like to mention the negative CO2 textile. Some examples, for example, the carbon negative algae-based fabric from algae knit, bio-based carbon sequestration textile, found it interesting also from living ink technology, regenerative agriculture cotton for fiber sheet, carbon negative wool, Savory Institute plant-based carbon sequestration fabric, Pangaea sea fiber, Disselenium leather for microwork reishi, and bamboo and hemp textiles from bast fiber technology. Maybe will be interesting for the future. And now speaking about before I'm leaving and giving the floor for Pepe, the next webinar will be on 3rd of September. You have already a link to register on ECC page, and the XBUILD-EU will be in the next time on LinkedIn as well. And now I would like to give the floor for Pepe. Yeah.
Hello.
Pepe, are you there?
Yes. Can you see me?
So I would like to present Pepe. Pepe Costa is a CEO at RetiCycle. He's expert in sustained traceability and ethical sourcing across the textile industry value chain. So Pepe, please, the floor is yours.
Okay. First of all, thank you for having me. Let me share my screen.
Pepe, we don't hear you.
Can you hear me?
No.
Oops. Let me see what's going on. Can you hear me now? Now it's okay? Excellent. Okay. So yeah, let me show my screen. Okay. So first of all, thank you for inviting me to this event. And yeah, let me introduce myself. I'm Pepe Costa, CEO of a company. It was founded back in 1984. We've been in the textile since there. And since some years ago, we are dedicating to develop sustainable solutions for the textile industry. Okay, we started with a traceability solution, and is what I'm going to explain today. Is our company, we are doing two things: the physical and digital traceability. On the digital traceability, we talk about RetiCycle, which is a development from my company. We developed in-house, which is a digital twin. It's a digital twin mass integrity system. Why is this important? Because when we talk about sustainability, sustainability, we say without proper traceability, it's something not very, sometimes not very serious. So what we do is to create a digital twin that creates a timestamp, geolocalization, and a weight measure of every lot in a production, and then by this way we are able to follow or to grant this digital traceability. Oops, sorry. excuse me, my phone went out. And what I say, we are also working in physical traceability. This is in combination with a German company called Tyler-Lux. At Tyler-Lux, we do three things. First of all, inert inorganic pigments. That is this kind of powder that we blend in the raw materials. These pigments have a hyperspectral profile. It means that we have these photoluminescent peaks in the ultraviolet, visible, and infrared range of luminescence. And with this machine, with this tool, we are able to visualize those pigments if they are in the raw materials. At the same time, we are also delivering a solution to dose this tracer. This tracer, when we put in the raw materials, we are later on able to detect in any step of the value chain. Means that if we put in a recycled cotton, for example, we will be able to detect in the yarn, in the fabric, in the garment, and eventually in the waste of this garment or this fabric. This is a very interesting tool. It has two advantages to put a physical tracer in the materials. The first one is that you are able to make sure that your claims that you are sustainable or are sustained on a strong base. And secondly, we can also detect the dilution of the traces. So basically, when, let's say, going back to this example of we having a 25% recycled content, how do you know in a finished garment it's a 25 or it's a 15? You can never know. You just trust the documentation. If this recycled content contains the tracers, we can detect this 25%, so we can make sure that your claims on recycled materials is legit, is real. So the combination of both things, we talk about this digital twin mass integrity platform together with the physical tracers, gives you a very strong way to help, let's say, prove the claims of sustainability or traceability in the textile world. The platform goes like this, where you have all the value chain actors are identified, and then every movement between the actors is also identified univocally, and we can later on find in a map the source or the movement of the raw materials in every step of the value chain. The mass integrity feature means that you can only produce what you have received from previous actors in the value chain with the quantity that they have transferred with you. The system works with the transaction certificates. It means that every actor issues a transaction certificate with the goods or the quantity of material that they have received previously. This way, we are working in different materials, because the traceability, as you can imagine, it's widespread in any kind of material. In the case of the cotton in Spain, we are tracing from the seed, from the point where you plant the seed in the field. Okay, let me show you a quick video. Excuse me. Yeah, this is a video of how we put a QR code on the seed bag, and the farmer, with an app developed with a platform, scans the QR code, this unique QR code, and by doing so, we have the exact location of where the seed has been planted. This way, well, you can see, I just killed the video here. You can see that by this way we are able to geolocate exactly where the seed has been planted. Okay, and then just review this example, I want to highlight, these are the locations originated on the system with this solution, and having this, let's say, initial point of the sewing of the cotton, we are able to, with this mass integrity that I referred before, go from cotton seeds to cotton bales to the ginning to the yarn to weave and finish and to the production. Okay, we are doing the same with recycled material. We are geolocating where the recycled clip, the clip is what we call the post-consumer waste scrap, or the industrial waste which is coming out from confection, right? We geolocate where this waste is generated, and then with this system, we also geolocate where the recycled fiber is made, and then we follow up to the production site. One example that I want to highlight is the collaboration we have with Recover Fibers. Recover is using Tylolux traces on all his recycled material. You can see the image of his installation in Alicante, in Bañeres de Mariola. And here you can see, maybe I can zoom in, you can see the system, Tylolux system, which in the case of the cotton, we are putting a viscose. This is a viscose cone that goes into this machine. And this machine cuts the yarn of the viscose that contains the traces, and with pneumatic, with this tube, we have pneumatic pressure and goes into the bale press. This is the bale press of the recycled cotton. So every cotton, you can see here, every cotton of recycled material from Recover contains a tracer, and this way they can prove the certainty of the origin. They can prove that the cotton which is recycled, it's clean, has no pollution, has no any harmful material that later will go into making the yarn or making the garment. And by the way, you can later on detect the Tylolux tracer in every step of the value chain, as I mentioned before. This is a very good example of how the system or how our solution works. Okay. Other things that we're doing on the tracing, as I said before, we can trace any kind of material with this combination of physical and digital traceability. And in one case, we are developing this waste of polymeric materials like PET and so on, where we can geolocate where the waste is collected, and then the waste is sent to a recycling and sorting and recycling plant. Then this plant creates the material to later on make an extrusion. And at this point, we can put the traces on, and with the traces in the material, then we can track up to the production and the final garment. Other examples we are doing, well, this is for the leather, which is we having here, our solution goes a little far beyond traceability, because with the leather, we are detecting that is not coming from deforested areas. And we are analyzing by satellite the picking where the animals are grazing. Then we track from the farm and forest to the where the hide is removed from the animal, and then where there is a trader that also let's say gets this hide and sends to the tannery to the leather manufacturing, till the finished product. So the traceability, it works for many textile or not textile, because leather is not textile, but products that are related like this. Other things that we are doing is this wool traceability. same. We are geolocating where the wool is cut from the sheep, and from the sheep we are tracing same concept of the QR code with APP, mobile APP, that by scanning the QR code we geolocate where this is taking place, and then by mass integrity we are having this traceability back to the production. All things rubber is not textile, but we're doing the same concept of traceability from the tree up to finished product. Some industry textile products contain rubber, like things for the car tire industry, but also for belts. These kind of industrial belts for logistics and so on contain rubber, and because this is affected by UDR regulation, we can provide this traceability. One idea of how the transactions goes and so on. It's another concept different from the textile, but it's the same idea, where you have a small farmer, you have dealers, and we keep this mass integrity on the system. This is we're doing also for cocoa, cacao. Well, this is other things we are doing also for wood, where wood, part of the wood or the viscose comes mostly from the wood, and then we are also having this solution, tracing where the wood is made, and then you can see all the supply chain from forest to timber, sawmill, merchant, and so on. Presentation is more kind for the furniture industry, but it might serve also as well on solutions for the viscose or for these kind of industries if they need. Okay, this is again transactions, flows, and so on. I will go short on this deforestation analysis that we are performing in our platform if it's required, where we're using different tools to detect whether the origin of the raw materials are deforested or not. This might serve for the materials that you mentioned, Oksana, on this pineapple, on different agricultural feedstock that is waste that is now converted into the fiber. If the supply chain needs a traceability solution to detect that this is not coming from deforested areas, the tool is there, is available. Just go through this kind of how the features of the platform, how it works. Okay, and for the UDR, what the European Commission is asking is for this GeoJSON format file of the origin of the materials. Going fast, we are also tracing waste. So imagine you have industrial waste. We can have the traceability for materials that later on will convert into raw materials for textile. We can have this mass integrity platform, which it's moving along as we are the raw materials get transformed into the value chain. Other things that we do is we are having this seal that creates this digital twin for what the seal has closed inside. So, just to go short, it's a solution again to enhance this digital traceability. And everything is integrated in the supply chain for the materials, where we can customize for everyone, for every actor, and we have this control of the digital twin. We have transaction certificates to move the quantity along the journey, and then later on you can review the map of the materials that moved along this on this value chain. And finally, we are collaborating with these entities. I'm missing the logo of because this is the old logo. Sorry, I will amend it. Okay, and because now it's
no problems.
Cat. Yeah, Textile Cat. Yes. I will ask you later on if you can send me the new logo. And yeah, you can reach me out anytime here at LinkedIn, or you have my mail, you have my mobile phone as well. And yeah, I'm open to questions or to solve any doubt if it's any question to mention.
Thank you, Pepe. Yeah, now I would like to open the questions and answer session, maybe short, only 1 minute, if there are some questions.
Sorry.
If not, we are always in contact on our via our webpage, textiles.cat, and as well in LinkedIn. You can find the xBUILD-EU project on the ECC page, as well on LinkedIn. And you can follow more news and other webinars. And as well, I hope you are joining us today now in some minutes at the info day for the second call of the xBUILD-EU project. I would like to thank you everybody for joining us today and wish you a wonderful rest of the day. Bye-bye. See you soon. Bye. Thank you.